Imagine an aircraft that never lands to refuel an aircraft powered by a system so unconventional that even engineers struggle to classify it. For years, rumors surrounded Chikumbutso's mysterious RF-based energy generator, a device many claim can convert radio frequencies into continuous, usable power. Today, we dive deeper than ever before into the innovation that supposedly keeps his self-powered aircraft in the sky. Not rumors, not speculation, but a clear breakdown of what might actually be happening inside this machine and why it captured global attention, raised eyebrows, and sparked silence from powerful institutions. The idea of a self-powered aircraft instantly sounds impossible, yet Chikumbutso's creation has circulated online through scattered footage, interviews, and whispers in tech circles. For many viewers, he appeared as a hidden innovator, someone working with limited resources, yet producing engineering designs that disrupt traditional thinking. Videos of the aircraft, though rare, show a compact, lightweight craft that supposedly operates without fossil fuel, batteries, or solar panels. Instead, its core is said to rely on a radio frequency energy converter that transforms ambient electromagnetic waves into continuous propulsion power. Skepticism grew because this technology contradicts conventional physics. Experts argue that ambient RF energy is too weak to power even a household light bulb, let alone an entire aircraft. But supporters counter that Chikumbutso doesn't use ordinary RF harvesting. They claim his technology manipulates resonance, field interaction, and tune frequencies in ways not yet fully understood or perhaps not yet acknowledged by mainstream science. This tension between belief and doubt built the mythos around the aircraft. Was he a genius working ahead of his time, or someone misunderstood by a world too rigid to consider unconventional solutions? Regardless, the curiosity surrounding the craft never faded. Instead, it intensified with every unanswered question. To understand the claims, we need to explore what the RF generator is supposed to do. At a basic level, RF energy is all around us: broadcast towers, communication signals, natural electromagnetic fields. Most RF harvesters collect this energy in microwatts or milliwatts. But Chikumbutso's device allegedly amplifies the energy through a proprietary resonance process, producing a continuous electrical output strong enough to run motors. According to accounts from people who witnessed demonstrations, the RF generator doesn't operate like a battery, capacitor, or fuel cell. Instead, it behaves like a persistent power loop. Once activated, it maintains output without external charging. Some compare it to a scaled-up crystal radio principle, others to Tesla's wireless energy concepts, and some to field-based amplification mechanisms. The unusual part is that the generator seems to run cool, without excessive heat, which contradicts typical high-power electronics. It also reportedly produces stable voltage output with minimal noise, another unusual trait if it were simply harvesting ambient RF. These claims raise the question, is it harvesting, amplifying, or transforming energy? Critics propose simpler explanations. They say the demonstrations might have hidden batteries or that measurement tools weren't accurate. Supporters push back, saying the tests were conducted in open environments with no wiring and that engineers were present. But regardless of which side is right, the idea of an RF-powered aircraft instantly challenges conventional logic. And that's why people are fascinated. If even a fraction of this working principle is real, aviation and global energy would fundamentally change. When viewers hear self-powered aircraft, they often imagine futuristic designs, sleek shapes, silent engines, or hovering platforms, but Chikumbutso's prototype is far more modest. It resembles a compact personal plane with a lightweight frame, simple control surfaces, and a central housing where the RF generator is installed. Contrary to expectations, it doesn't have exotic materials or alien-like components. Instead, it looks practical, almost too ordinary for a machine claimed to break the rules of propulsion. Inside the craft, the generator supposedly powers an electric motor connected to a propeller system. The motor is said to draw continuous current from the RF converter, never draining, never dropping, and never requiring recharge. If true, the propulsion behaves similarly to standard electric aircraft, but with a power source that never depletes. What fascinates viewers is the lack of visible fuel tanks, battery packs, or solar surfaces. The aircraft's simplicity becomes part of the mystery. How can something so plain hide something so extraordinary? In expected footage, people anticipate seeing close-up shots of the converter, wiring, output meters, and motor performance. They want to see the aircraft take off, hover, or maintain flight in a way that appears sustained and self-reliant. This is the moment of truth most viewers seek: clear, undeniable proof that something unconventional is happening. The controversy around Chikumbutso's RF innovation isn't based only on scientific skepticism, it's rooted in history. Every time an inventor claims to produce energy from unconventional fields, the world reacts in three ways: fascination, doubt, and sometimes suppression. The idea of a device that could replace fossil fuels, rewire aviation, and disrupt global energy industries is simply too large to ignore. Scientific institutions push back because his explanations rarely align with known physics. Engineers argue that extraordinary claims require extraordinary evidence, and that without published data, replications, or peer-reviewed documentation, it's impossible to verify the technology. Supporters respond that disruptive innovators rarely emerge from universities, and that history is full of breakthroughs initially dismissed by experts. Some people point to interviews where Chikumbutso claimed he faced pressure, threats, or sabotage attempts. Whether these claims are literal or dramatic, they add a layer of intrigue to the entire narrative. For many, the controversy isn't just about the technology, it's about the environment surrounding it. If the RF generator is real, it poses a threat to industries worth trillions, and that alone is enough to trigger resistance. But if it's not real, then the entire saga becomes a cautionary tale of hope, belief, and misinterpretation. One thing is certain: people don't watch videos about this aircraft for entertainment. They watch because somewhere in this story there's a possibility, however small, that everything we know about energy might change. Imagine a world where aircraft no longer depend on fuel, where cargo planes cross oceans without refueling, where drones stay in the sky indefinitely, and where private aviation becomes accessible to millions. A self-powered aircraft wouldn't just change transportation. It would reshape geopolitics, global trade, and national security. Industries built on fuel production would face unprecedented disruption. Aviation companies would scramble to adapt. Defense forces would reconsider strategies. Remote regions could access transport without relying on costly infrastructure. More importantly, smaller countries with limited resources could suddenly innovate on equal footing with large nations. A technology like this could shift global power balances and empower regions previously reliant on imports. For regular people, it could spark a wave of ultralight personal aircraft, emergency response vehicles, and autonomous delivery systems. The potential is massive, but only if the system works reliably, scales efficiently, and can be reproduced by independent engineers. And this is why the story matters. Whether or not the technology is proven, it sparks a crucial question. What if innovation comes not from billion-dollar labs, but from unexpected places? What if the next major breakthrough is hidden in a workshop instead of a corporation? The world is watching not just because of the aircraft, but because of what it represents: a challenge to the boundaries we've accepted for decades. If Chikumbutso's RF-powered aircraft is real, it could mark one of the most transformative moments in engineering history. But until complete evidence emerges, the mystery continues to fuel curiosity, debate, and imagination. Perhaps the truth lies somewhere between scientific breakthrough and misunderstood experimentation. Or maybe it's waiting to be rediscovered by those willing to look deeper. What matters is the question it raises: are we truly at the limits of energy innovation, or are there still discoveries hiding in plain sight? The future may reveal much more than we expect.